Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, identifying transformations that map a quadrilateral onto itself. So in this case we have a square. M intersects the two vertices, so it's going through those corners there. M bisects each side it passes through, so it's perfectly in the middle of those two sides. And Y is the center of the square. Cool. So which transformations must map the square exactly onto itself? So that must is important, because if you can just find a way to do it, that's not the same thing. It has to be, there's no choice. If you do this, it will always map onto itself. So a clockwise rotation about Y, so about the center, of 180 degrees. So if I take this whole thing and flip it upside down, will it land on the same thing? And that is true. It will do that. Okay. Reflection across N, so that means taking this over the middle and flipping it. Will this side match this and vice versa? And that is true as well. Reflection across M, so the same thing. If I take these two and flip them like that, will also work. And a counterclockwise rotation about Y of 270 degrees will actually also work. So if I take this and go counterclockwise, so I basically turn this all the way 3/4 around, it'll still be a square. Now this is, you might look at this and be like, well, why wouldn't that work? This is because it's a square, all these kind of line up. Imagine, if you will, if you have a triangle or something like that, maybe even a pentagon. If you cut across like this, you're going to have different shapes on either side, so that one of those reflections wouldn't work. Or if you have a triangle and try and flip it upside down, you won't be the same thing for that 180 degrees. So there are times it won't work. Squares are just very useful in terms of symmetries and stuff, so there's a lot of them for there.